Did you know the universe might be acting a little like your phone's GPS when it suddenly starts recalculating your route? Except imagine it doing that while you're already going 70 on the freeway. That's the kind of cosmic confusion scientists are dealing with right now. One of the world's top physicists, Nobel Prize winner Adam Rees, recently admitted something big. The roadmap we've been using to understand the universe might be seriously off. Thanks to the James Webb Space Telescope, basically our giant all-seeing eye in the sky, we're getting clearer, deeper looks into space than ever before. And what it's showing us is kind of shocking. Turns out, the universe isn't just expanding. It's expanding way faster than our current models predicted. Like, hit the gas when you were expecting a cruise kind of faster. This discrepancy even has a name, the Hubble tension. Sounds technical, but really it's science speak for we're stumped. So what now? Is the universe broken? Are our calculations just outdated? Enter a bold new theory, courtesy of a sharp team of researchers from the universities of Bonn and St. Andrews. These folks think they found a possible explanation, but there's a catch. Their idea only works if we're willing to let go of one of science's biggest sacred cows, Einstein's theory in gravity. Yup, to fix our cosmic math problem, we might need to gently set some of Einstein's legendary ideas aside. No offense to the big guy, he had a good run. But hey, science isn't about holding on to what we think we know. It's about constantly updating the map when the road ahead looks nothing like we expected. So what do you think? Is the universe playing tricks on us? Or are we just now starting to uncover how much deeper the rabbit hole goes?
In today's video, we're diving into what the James Webb Space Telescope just spotted, way out there in the deepest corners of space, and how one bold new theory might force us to rethink everything we thought we knew about the universe. No exaggeration, Webb hasn't even been up there 3 full years, and it's already shaking the foundation of modern cosmology like a snow globe. It's turning long-held theories upside down, sending our cosmic rulebooks straight into the recycling bin. Take this. Galaxies that are way too massive showing up just a few 100 million years after the Big Bang. Yeah, those shouldn't exist. And then there are the mysterious red blobs, unofficially and very dramatically nicknamed universe breakers. Plot twists everywhere. But here's the real kicker. Those galaxies might not be galaxies at all. Some astronomers now think they're actually enormous black holes in the making, like baby monsters growing fast and hungry at the dawn of time. If that's true, the picture gets a little clearer, and maybe a little less terrifying. Turns out the universe might not be breaking all the rules, at least not yet. So, hold off on rewriting every physics textbook. But also, don't get too comfortable. Because just as we catch our breath, another cosmic curveball is already in motion. The universe is expanding way faster than expected, and that's got scientists losing sleep. Let's rewind to where this all started, over 100 years ago when Edwin Hubble, yep, the guy the telescope's named after, looked into the night sky and discovered something huge. The Milky Way wasn't alone. Not only were there other galaxies, but they were racing away from us in every direction. It was like finding out the Earth wasn't the center of the solar system all over again. Except this time, we realized our entire galaxy was just another face in the cosmic crowd. That discovery kicked off the idea that the universe was expanding, stretching out like a balloon. But now, thanks to Webb's precision, we're realizing it's not just expanding, it's speeding up. Way more than expected. And that's where things get messy again. Scientists have a name for this cosmic contradiction, the Hubble tension, a polite way of saying our math doesn't match reality and we don't know why. So here we are, galaxies that might be black holes, expansion that makes no sense, and a telescope that seems to reveal more questions than answers. This isn't just another space update. This is a full-on astrophysical cliffhanger with mystery, high-stakes science, and maybe even a dash of cosmic rebellion. So buckle up, because space isn't done surprising us, not by a long shot.
But this time, the idea actually stuck, and that's when things really started to heat up. So let's rewind for a second. If the universe is expanding right now, it must have started from somewhere, right? That somewhere would be an unimaginably small, insanely dense point. Boom, the Big Bang. Nope, not the sitcom. the actual cosmic beginning. For a while, scientists were feeling pretty confident with that story. Everything was lining up. The math, the models, the observations, it all made sense. Until the 1990s rolled around and tossed in a plot twist that rocked the entire script. Turns out, the universe isn't just expanding, it's speeding up. Hold up, what? That's like throwing a ball in the air and watching it not slow down, but accelerate upward like it just got launched by a jet engine. It goes against everything we thought we knew about gravity and motion. So, how do you explain that? Enter dark energy. Scientists came up with this mysterious force as a way to patch the hole in our understanding. Dark energy is like gravity's rebellious sibling. It doesn't pull things together, it pushes them apart. Hard. The weird part? We have no idea what dark energy actually is, but we do know this. It's powerful enough to override gravity across the entire universe, which shouldn't even be possible, and yet here we are. Now picture this. You're watching a balloon drift into the sky. You expect it to float away slowly, right? But instead, it rockets off like it's on a SpaceX mission. That's basically the situation astronomers are facing when they try to track how fast the universe is expanding. And here's the kicker. The numbers don't agree. Depending on how you measure it, by observing nearby galaxies or looking way back in time using cosmic background radiation, you get totally different results. That mismatch is what scientists call the Hubble tension, which sounds more polite than major headache, but yeah, it's a real issue. So how fast is the universe really expanding? Well, in theory, we should already have that nailed down. The standard model of cosmology, our best blueprint of how the universe works, was supposed to lock that value in. But reality? It's throwing curveballs. And now, scientists are back at the drawing board, wondering if the math is wrong, the tools are off, or if something even bigger is going on. Something that could change everything we thought we knew about the cosmos.
All right, so here's the deal. According to our best cosmic playbook, the gold standard model of the universe, we're supposed to know how fast the universe is expanding. That number? It's called the Hubble constant, and it should be right around 67 kilometers per second per megaparsec. Now, just so we're on the same page, a megaparsec is basically 3.26 million light years. In regular human terms, that's mind-meltingly far. Like, you'd run out of playlists on the road trip far. So, based on this model, for every 3.26 million light years you travel out into the universe, galaxies should be drifting away from each other 67 kilometers per second faster every second. That translates to about 244,000 kilometers per hour. Let that sink in. That's like cruising across the solar system in just a few hours. Definitely not your average highway speed. But here's where things go completely off script. When scientists actually go out and measure this expansion using real-world tools, like exploding stars, supernovae, flickering variable stars, glowing red giants, and even warped light from massive galaxies, gravitational lenses, they keep getting a different answer. And not just a little different, consistently higher. The numbers say the universe is expanding at 73 kilometers per second per megaparsec, which equals about 264,000 kilometers per hour. That's 20,000 kilometers per hour faster than predicted. And no, that's not a rounding error. That's a drop your coffee level problem. Scientists call it the Hubble tension, which is a fancy way of saying something big doesn't add up. So, naturally, the cosmic brainiacs went back to double check. And this time, they brought out the big guns, the James Webb Space Telescope, our new all-seeing eye in space. Led by Nobel Prize winner Adam Rees and his team at Johns Hopkins, they reanalyzed the stars. And I mean really analyzed them. Not just the usual suspects like Cepheid variables and red giants, but also an elite class of stars rich in carbon, which act like perfect cosmic lighthouses. And guess what? Same exact results. Webb confirmed what Hubble saw, 72.6 kilometers per second per megaparsec. Solid, reproducible, verified. So let's break it down. 2 of NASA's top telescopes, multiple methods, dozens of peer-reviewed studies, all pointing to the same bizarre truth. The universe is expanding way faster than it's supposed to. And this isn't just an awkward math glitch we can brush off. As Rees himself said, it's not about some small mistake in the data. It's about something much deeper. We might not fully understand the universe at all. Which leaves us staring at one unsettling possibility. The standard model of cosmology, the one that's been guiding our understanding for decades, might be missing something huge. And yeah, if this keeps up, we might need to rethink the rules of gravity. That means possibly challenging the legacy of Einstein himself. No offense, Al, you've had a good run. The cosmos once again refuses to sit still and behave.
Just when scientists think they've cracked the cosmic code, the universe tosses in another twist, like a plot hole in a movie you thought had a perfect ending. So what's really behind this puzzling mismatch between what we think the universe should be doing and what it's actually doing? Why does space keep acting like it's following rules we haven't even discovered yet? Well, Nobel Prize winning astrophysicist Adam Rees has a few mind-blowing ideas. Buckle up, because they're not your average textbook theories. One possibility? There's a strange, exotic type of dark energy at work. Something more elusive and unpredictable than what we've accounted for. This force could be tweaking the universe's behavior from the shadows, messing with how we measure expansion. Another idea? There could be a brand new particle or mysterious field floating out there in deep space, completely unknown to science. Something that subtly pulls cosmic strings in a way we haven't yet detected. And then there's the most daring theory of all. Maybe we've been wrong about gravity. Yep, Einstein-level wrong. Enter one of the weirdest and maybe most genius takes on the Hubble tension yet. A theory so wild, it might actually work. A team of researchers from the universities of Bonn and St. Andrews is suggesting something radically different. What if gravity isn't broken, but we're just in a weird part of the universe? According to their work, the Milky Way might be floating inside a giant cosmic supervoid, a massive, mostly empty pocket of space. Think of the universe as a loaf of raisin bread, only we're living inside one of the holes where a raisin should be. Yeah, we're in the gluten-free section of the cosmos. Here's how it plays out. Cosmic maps, built from deep space surveys, have shown that the universe isn't just a chaotic mess of stars and galaxies. It's actually arranged in a giant web-like structure, with fixed strands called filaments, made of galaxies and dark matter, and huge empty spaces between them, called voids. Picture it like a spider web stretched across the universe with bubbles of near-nothingness scattered throughout. If our galaxy is sitting inside one of those bubbles, what researchers call an air pocket in the cosmic cake, then things start to get weird. Why? Because as galaxies on the outer edge of this void move toward denser regions, it makes everything inside, including us, look like it's speeding up and flying apart. It's not that space is expanding faster everywhere, it's that from our vantage point, it just looks like it is. Kind of like sitting in the eye of a storm. You're calm, but everything around you seems to be moving faster. The researchers say this illusion could be throwing off our calculations and making us think the universe is growing way faster than it should. In other words, the Hubble tension might not mean the universe is breaking the rules, we just might be looking at it from the worst seat in the house.
But hold up, there's the twist. These so-called supervoids that might explain the weird acceleration we're seeing, they're not even supposed to exist. At least not if our standard model of the universe is actually correct. According to the current rulebook of cosmology, matter in the universe should be more or less evenly spread out. No giant empty pockets, no bizarre patches of nothingness, just a well-balanced cosmic soup. And yet, here we are. Astronomers have found galaxies over 600 million light-years away that are racing off at nearly 4 times the expected speed. That's not just a rounding error, it's a giant cosmic red alert blinking across the data. So what the heck is going on? to really shake things up, a group of researchers decided to toss out Einstein's traditional theory of gravity altogether. Instead, they ran simulations using a rebel physics model known as MOND, short for Modified Newtonian Dynamics. Think of MOND as the punk rock version of gravity, loud, rebellious, and not invited to the mainstream science party. It was first introduced in the 1980s by Israeli physicist Mordechai Milgram, and for decades it's mostly lived in the shadows of astrophysics, dismissed by many but never fully forgotten. Instead of explaining weird cosmic behavior with mysterious stuff like dark matter or dark energy, MOND takes a different route. It changes the way gravity itself works, especially in places where acceleration is super low, like the far edges of galaxies or right in the middle of a supervoid. And here's the kicker. MOND actually predicts these supervoids. No dark energy needed, no mysterious cosmic forces, just a different set of rules for how gravity plays out when it gets stretched thin. It's kind of like realizing your TV isn't broken, you've just been using a remote set to the wrong brand. Suddenly, everything starts to make sense. Now, to be fair, MOND is still a controversial theory. A lot of scientists are skeptical, and it doesn't solve every mystery. But if it turns out to be even partially true, it would mean rewriting some of the biggest, heaviest, most trusted physics textbooks on the shelf. So here we are asking some massive questions. Are we really living in a giant cosmic void? Was Einstein kind of wrong about gravity? And is dark energy just a temporary label for something even stranger? Whatever the truth turns out to be, one thing's for sure. The universe isn't just bigger than we thought. It's way weirder than we ever imagined. And that, friends, is where things really start to get juicy.
So, here's the big idea. If Mordechai Milgram's MOND theory is actually right, if gravity doesn't quite follow the rulebook Einstein gave us, and this whole Hubble tension that's got scientists pacing the halls at midnight, it might not even be a mystery at all. Instead of juggling two clashing values for how fast the universe is expanding, we might just need one single number, a unified expansion rate that makes everything click. That weird mismatch in measurements? MOND says it's just a side effect, a natural result of how matter is clumped together unevenly across space. Think of it like this. Imagine you hit a traffic jam in a couple neighborhoods and assume every road in the city is broken. But maybe it's just where all the drivers happen to show up at the same time. It's not the roads, it's the rush hour. Pretty neat fix, right? But, cue the dramatic music, there's a catch. For MOND to become more than a fringe theory, we'd have to throw out some core ideas that modern physics is built on. We're talking foundational stuff, especially about how gravity works on large scales. If MOND is going to leap from cosmic conspiracy theory to science textbook material, it's going to have to knock Einstein down a peg. And let's be honest, that's a tall order. It's kind of like walking into your calculus class and saying, "Hey, I figured out a better way to do multiplication." Unless you've got some serious evidence, don't expect a round of applause. Still, if the universe is dropping hints, giving us strange data points and head-scratching anomalies, we'd be crazy not to pay attention. Whether MOND turns out to be the answer, or it's a new kind of particle, or something so strange we haven't even dreamed it up yet, one thing is crystal clear. The cosmos is not done messing with our heads. And when Nobel-winning scientists start scratching theirs and saying, "Yeah, we might have missed something," maybe it's not panic time, but it's definitely time to lean in and listen. Because whatever comes next might change everything we thought we knew about the universe.